Why, hello again, and welcome back to another video of DSGE's kind of progress. Today I finished up the last few of these tasks I needed to get done for the GLW, so it's done. Had to add an extra one because in order to use a UBO inside of a shader, you have to basically allow to create a block, a uniform block for it. So you need to get access to that to create a binding to it. So let's go down here. And as you can see, don't have much images for this. What this allows us to do is have a buffer that can have access to other uniforms and different shaders, so it makes it easier to say do a camera system, for example. Let's go to the code real fast. I'll show you. Let's show you some shader code real fast. As you can see, I moved the view and projection matrix to this camera UBO, and it's also in the one that handles Texture2DArrays as well. This means that these UBOs, if you bind them with the binding system that OpenGL comes with, you can use them across different shaders, and you don't have to update them each time you want to call shader. Now you might notice I left model out of this. The model matrix is the matrix that basically transforms the local object. So we kind of need to keep kept at the shape, kept in the shader just like a normal uniform. Because if we update it in another shader, it will kind of do some funky stuff. Well, it might not. Who knows? All right, moving on. The next thing I added was texture arrays, or specifically 2D texture arrays. What they do is that you can have not just one image that's associated to a texture, but you can have one to multiple images, or one to n, for example. For this particular, I still have my cold. For this particular example, I have four images for my icon. I have just a regular yellow one, a green one, blue one, and a magenta one. And I can actually let me make sure this is compiled real quick before I do anything. I forgot to compile it again. No. Okay, there we go. It finally compiled. If we go to then run, as you can see, it's just a regular one. However, if I press the tab button, it's now applying the texture array that I created in the main file. And we can tab back if we want to. Now what I'm going to use texture arrays for is going to be for tile maps, and I'm playing around with the idea of using it with a character like map thing, so you can have as many animations that you want, which should be pretty awesome once I start actually working on the other systems that are going to be in this little engine. You might be wondering how this works. We'll go through it real quick. In the main kind of section where the main entry point is, I've made a small test app to basically just, to do a couple things like move the character around the screen and just testing for right now, because this is not going to go, and this is probably going to get removed, so I can move this to like the game subfolder on here eventually, because I'm in a need to make a game sub app that will run if you execute the executable just normally. Oh yeah, I forgot to mention. In order to use the editors in this engine, it's actually just the same executable as the game. You just do something like this: run app, and then say, I don't know, editor. That's how it's going to work. So all the editors will be built into the game engine, the game executable, and you'll have an option to turn them off once you release the game. That's probably a good thing. That's one thing I need to add to the issues at hand. Okay, let's back to this. The difference between creating a regular texture from like a file, for example, is that instead of you sending just one location for a file, you have to send multiple ones, which I'm technically using a vector, std vector for right now. Later on, I'll probably add my own kind of core library that has different data structures that we can play around with. The other thing I had to do with getting that effect to work was create its own vertex buffer with different parameters, because texture arrays, unlike Texture2D's, which takes in 2D coordinates, the Texture2D array also takes in a Z chord to specify what layer you're using within that 2D texture array. So as you can see, 0's for the yellow one, this one's for green, this will be for the blue texture, this one will be the magenta one. So yeah. The last thing I added was a Framebuffer, which Framebuffers are pretty awesome. They allow you to render a scene to a texture, and then you can re-render that texture and do whatever you want to with it. For right now, the only thing I want it to be used for is scaling the scene. I might redo it where, depending on the resolution. Let's show you where it is in the renderer code. And if you start a frame, it will basically bind the frame buffer. And internally, the engine uses 640 by 480 if the screen ratio, the resolution of the screen, is at I think it's 11 by 9 or something. Oh, 16 by 9. My bad. It will use 640 by 360 to just match that ratio, so it won't stretch across the screen. That will come in eventually once I actually add in a tool that will allow you to change the settings inside the game itself. And that's one thing I'm going to have to add an issue for. But currently, if you go to main and run the game again, this is at 640 by 480. If I were to go down here, multiply it by 2, multiply this by 2, which I think 640 is 2. I think it's 1280, and this is I can't math right now. 480 times 2, 960, which is a pretty standard resolution. And go back, oh sorry, and just compile it with scones. Oh my god, scones is being slow today. Well, it's probably because I'm recording, so that kind of makes sense. There we go. Alright, see again, run, boom, bigger. I am using linear filtering for now for it. I see it's wobbling there. That might take a look at the code, but oh well. The other cool thing about the frame buffers, like I said, you can do changes with it with the shader or inside the code itself. Let's see here. Where is render CPP? And it's in the end frame. As you see it, you don't need to worry about it when you're rendering inside the engine. The rest of the app, it's only for the renderer. Let's see here. You can change up the texture filtering if you want to. Like for right now, I'm just doing linear, but we can change it to, like, I don't know, a nearest filter if you want to, like this. Can't spell right now. Spell. All right. And you might notice it's a lot more pixelated now. That's because the nearest filter is not really a filter, just puts it takes an input, then just gives you output right away. That's all it does. So that's why it's pixelated. Some other fun things you can do with this, because it's a post-process, you can go to the shader. Where are you? Aha, here you are. As you can see, it's quite simple. But if I were to just do, I don't know, do that and do a vector for color is equal to that texture, text 0 to be, and just do color that RGB equals 1 minus color that RGB. And then you just set the output color to the color. And we don't have to compile it because it's a shader. It's being loaded in a file. You invert the screen color. So we can do some post-processing with this if we want to. What else can we do? Let's look at some effects real fast. Just for funsies. Processing. I don't know. There's a bunch of things you can do with post-processing. Oh, pixelization. What if it's in one of my old... let's see here. I remember using that in like a really old project from like years ago. Is it? I think it's engine. Excuse me. Yeah, I think it's this one. Oh, texture core. That's kind of awesome. Aha! Pixel! Yeah, that one. Let's go look at the shaders real fast. Where are you? I trust myself. There we go. Oh wow, this is really old code. It's in version version OpenGL 2. That's nuts. Where's that pixel code? I want it. Pixel, where are you? That's the wrong one. Where are you? Oh, here it is. Ah, much better. This is the one. Here it is. Let's just copy and paste this code and see what it does. Go to my output one. We're going to do this. What is size? I don't know if that's gonna work or not. Yeah, let's do something else. Grayscale up. That doesn't look too hard. And a quick way to do that is just do color RGB equals color. We'll just do this color dot R plus color G plus color dot B. Then you divide it by 3, 0, and that should give you just black and white. Nope, it decided to say no to me. Why? Oh, I'm an idiot. And you just do this. This would make it into a vector 3. Why hassling me, my dude? Oh. Look at me, I'm terrible at coding. There we go. Now it's black and white. And let's do one more basic one. I'm going to end the video. Oh, so it's just, let's do this. Alright. And then we do color.rgb and multiply it by this, and this would do a SEPA filter, which is that kind of brownish kind of screen filter thing. So run it, see what it looks like. Yep, SEPA. So yeah, you can do some interesting things with this. Another thing you can do with this, well, what the hey, let's do one more example. The text chords are basically a 0 to 1. It represents like how the texture is interpolated across the screen. So if you can scale it up with any value that you want to. It could be because 0 to 1 is are what is known as uniform numbers. So you can do uniformly scale them to any value that you want, which is pretty cool. So let's instead of having that, we can do something like this. We need to grab actually we do need this. Do it, and we need float scaled. Maybe we should do we should just do it as an int. Scaled hi scaled y equals int let's see here, b, and we're just going to go y times 640, not 0. And let's make sure this works real quick. I forgot to save it. Sorry. Alright, we're back to being normal again. So, and what we're going to do if if scaled y two is equal to 0 and discard. And we're going to put this color output into an else statement. Just to make sure that's branching correctly. And it's doing something stupid again. Oh. Yeah, I can't really code right now while I'm talking. This is terrible. Oh well. It's doing something wonky, but oh well. What are you doing? Let's move it to like 960. Ah, my foot. And look, we have scan lines. Ah, there we go. Scanline rendering. Which is pretty cool. So yeah, you can do a lot of things with this. I wonder what it'll look like with by doing inversion. See how insane it looks. That is actually really cool looking. And you can do interesting things like this. You can actually scale this up to 4 if you wanted to. And I think 2 is probably perfect. Yeah. It's like a giant white line up there. Yeah, you can do a lot of things with this. Give it a this and pop this out. Yeah, well, I'm going to end this video for this small little update. Y'all take care, and I'll hopefully see you in the next video. Take care, everybody.